This video is called Ionic Compound Nomenclature Part 1, and we will be going over how to write formulas for ionic compounds, including those that have the transition metals. Just a quick recap of what an ionic compound is. These form when metal atoms transfer electrons to nonmetal atoms, forming two oppositely charged ions, positive cation and a negative anion. Because opposite charges attract, these are now going to attract one another into what's called a crystal lattice structure. This is the ionic compound that they will form. Okay. It's important to realize that even though ionic compounds are made up of negative and positive particles, ions, the overall compound has no charge and is neutral. The charges of the cations and the anions will balance each other out, and that's a key part when you're writing formulas for these compounds. You will need a periodic table indicating ion charges for both the cations, which are the positively charged ions, and the anions, the negatively charged ions. Just to remind you, the charge above a column means that all of the elements in that column will form that charge of an ion. So for example, all the elements in group 2 will form a 2+ ion. These are the transition metals that are outlined in red. Tin and lead are included in that grouping. These are your elements that do not have a charge written above their column, and therefore you will have a Roman numeral that will tell you the charge for these elements. These are all elements that form different atoms, ions. They may form 2+ or 1+ or 3+, so the Roman numeral is needed to know what cation to use. On your common ion list, which is another document you should download and have ready, on the right side, we actually have a list here of the transition metals with their Roman numerals and the charges that they form. What you want to remember when you're writing the formulas is that the charge is the Roman numeral. It tells you exactly what charge that cation will form. Okay, so we're going to move to the .cam. So we can do some examples. There you go. All right. So just remember we covered this before, but I just wanted to put this here again. Okay, it's always, when you're writing a formula for an ionic compound, there is always the cation is first and then the anion, right? And this is kind of the process. You write your ions out, you look at their charges. If their charges automatically cancel, then your formula is just putting the two symbols together. Let's going to do a couple more of these before we move on to what to do when the charges don't cancel. So let's look at aluminum phosphide. I have to go to my periodic table to find aluminum. Tells me it forms a 3+. So my cation is aluminum 3+. And it doesn't matter if you write 3+ or +3. Phosphide. So recall that for anions, the last part of the name changes. You take the root of the element name and add "ide." So phosphide must have been phosphorus. So we look up phosphorus, and we see that it's in the 3- column. So this is going to be P3-. These charges cancel one another automatically. They equal 0 when you put them together. So our formula for aluminum phosphide will be ALP. Now, what happens if the charges do not automatically cancel one another? When that happens, when the charges of the ions are different, you're going to do what's called the crisscross method, right? So let's go through a couple of examples here. Let's look at magnesium bromide. So again, I need my periodic table. I find magnesium. It's in the 2+ column. So my cation is magnesium 2+. Bromide must have been bromine. So I find bromine. It's right here in column 17. It has a 1- charge. So it's Br1-. These charges do not automatically equal 0. So you do what's called the crisscross method. Okay. And what happens here is you take just the number, not the charge. The 2 from the magnesium is going to come down and over across to the bromine. The 1 from the bromine is going to come down and over to the magnesium. Okay. These charges now become the subscript in the formula. You do not bring over the signs, just the number, right? So what you're going to get here is MgBr2. So this 2 from the charge on the magnesium became the subscript on the bromine, the bromide. The 1 also came down. The 1 is assumed. 1s aren't written in chemistry very often. Let's do one more of these examples. Let's do calcium nitride. Calcium's here, has a 2+ charge. So our cation is Ca2+. Nitride, nitrogen. We find nitrogen in the 3- column. So N3-. Again, we need to crisscross these charges. This 2 is going to come down and over here. This 3 down and over there. Again, just the number, not the plus or minus sign. This means in my formula, I have Ca3N2. The 3 from the nitrogen's charge becomes the calcium subscript, and the 2 from the calcium's charge becomes the nitride's subscript. The crisscross method is a quick way to do it. Let me show you, though, what this really means in terms of charges. Okay, let's look at magnesium bromide. This formula, MgBr2, means that in this compound, I have 1 magnesium 2+ ion and 2 bromide 1- ions. And if you look at the charges here, you can see that 2+ and a total of 2- will cancel out, making that neutral ionic compound. So crisscrossing is a way to write these formulas and still follow that observation that ionic compounds are indeed neutral. So crisscross the numbers, don't just move them over, also move them down and leave the signs behind. Okay, we also want to talk about transition metals. So all the examples we've done so far and that we did in class come from columns that have charges written above the column, so you know what charge ion these elements are forming. What happens if your metal is one of these transition metals in this outlined area, or tin or lead? So if you look here, tin and lead, there's no charge up here in their column. Same thing with these transition metals. Manganese, there's no charge here. In these compounds, there has to be a Roman numeral in the name, and that will tell you the charge on the ion. The reason for this is that these elements tend to form more than one type of cation. So for example, we talked about in class, iron can actually form a 2+ or a 3+ ion. So depending on which one is making up the compound, you'll get very different properties for those compounds. The Roman numeral in the name will indicate which of those 2 ions is in the compound. Okay, so if we look at some of these examples, and we actually did the first 2 together, so I'm going to skip down to some of these on the bottom. So just a reminder, the Roman numeral is the charge of the transition metal. It does not become, it's not how many of that metal you have. So let's look at something like cobalt-1 sulfide. Okay. Cobalt, you see the Roman numeral. It's there because cobalt does not have a charge on its column. The 1 means what we have is CO1+. We have cobalt with a 1+ charge. That Roman numeral told me that. This is the charge. Sulfide There's that IDE ending. That was sulfur. We find sulfur. Sulfur always has a 2- no matter what. Same process as before. If the charges don't cancel, you need to take them and crisscross them. So this 2 is going to drop over and under that. This 1 is going to drop over and down by the S. And you end up with CO2S. The charge of the sulfur ion became the subscript for the cobalt. The charge of the cobalt ion became the subscript for the sulfide. Notice there are no Roman numerals in the formula. Roman numerals are in the name to indicate the charge on that transition metal. All right. Let's try chromium 3 phosphide. Again, chromium, no charge on its column, so a Roman numeral is provided for us. Cr3 plus, phosphide, phosphorus. Phosphorus has a 3 minus. Now in this case, the 3 plus and the 3 minus, they cancel each other out. So we do not need to crisscross in this example. We just take our symbols and smush them together for the formula, CRP. All right. Change my camera. So that's the end of this first video, where we're just looking at how to write formulas for ionic compounds, including ones with transition metals. The next slide in this Nearpod will be your practice on this. And then the next video will be after that. Part 2 has to do with how to write formulas for ionic compounds when polyatomic ions are present. Thank you.